Okay, so what we're going to look at today is we're going to look at ratios. So anyway, a ratio is nothing more than a comparison between two numbers. For example, right now we could look around the room and we could have a male to female ratio. We have 6 females and 2 males. So 6-to-2 ratio, female to male. We could write it like that as a fraction. We could write it with a colon, or we could write it as 6-to-2. I prefer to write it as a fraction because when it's in that form, we can do a lot of things with it that we would with any other fraction. First of all, both the 6 and the 2 can be divided by 2 to give me a 3-to-1 ratio. Now, one thing that's different, if this were a fraction, we would just write it as 3 instead of 3-to-1. But since it's a ratio, we do have to keep it as a comparison between two numbers. We have to keep both numbers in it.
I was just going to ask that, so you can't have like...
3 is not a ratio. Yeah, 3 is not a ratio. And you would not do this either. Let's say I wanted to do a ratio in my previous class. Let's say I wanted to do the ratio of students who failed their test to students who passed their test. We had 12 students who failed to 8 students who passed. Well, that can be reduced. Both of those can be divided by 4 to a 3-to-2 ratio. I cannot change that into 1 and 1/2. I don't want a mixed number. I want a ratio. So that's the other big difference. I'm not going to split that up into a whole number and a fraction because there's not a whole number. It's not a fraction. It's a comparison. But I can reduce it similar to a fraction as long as I don't convert it into a mixed number. Or I might take, looking at these tables, a width to length ratio. They are 18 inches wide and 72 inches long. Well, the inches will cancel out. 72 and 18 are actually both divisible by 18, giving me a 1-to-4 ratio. Now, the inches canceled out. You might be asking, well, what units are being used there? Well, it doesn't matter. On that table, it doesn't matter whether we measure the width in inches, feet, or millimeters. For every 1 unit of width, there are 4 units of length. So the unit itself doesn't matter. It's the ratio, the comparison between them that matters. As long as we use the same unit for each measurement, it will be 1 unit of width for 4 units of length. In fact, all of these are set up like that. Notice there's no units in any of these ratios because here we're comparing people to people or students to students, and the same here, inches to inches. And that's actually a very important quality of a ratio, is a ratio can only compare 2 numbers with the same units or same labels. If I have 2 feet compared to 18 inches, technically that is not a ratio like that. But I can convert it from 2 feet to 24 inches. Now, 24 inches to 18 inches is a ratio. Inches divide out, I can divide both of those by 6, give me a 4-to-3 ratio. Again, I cannot reduce that to 1 1/3. It's not a mixed number, it's a ratio. So ratios compare things with the same units. What if we have things with different units? Let's say we send one of you on a road trip and you drive 365 miles in 7 hours. Well, there's no way I can convert miles into hours or hours into miles. There's no way I can make the same units in each of those numbers. This is not a ratio. This is what we call a rate. That is the first big difference between a ratio and a rate, is the ratio compares things with the same labels, rates compare two things with different labels. The second big difference, in a ratio, we'll often leave it like this, as 4-to-3 or 1-to-4 or whatever. In a rate, we most often convert it into what is called a unit rate. By a unit rate, I mean the bottom number of the denominator becomes a 1. So to turn that into 1, well, it's 7, so I'm going to divide by 7. That'll make it 1 hour. 365 miles also has to be divided by 7 then. Just like other fractions, you have to divide or multiply the top and bottom by the same thing. 365 divided by 7 is 52.142857143 approximately. What? Yeah, I'm sure. Why? You come up with something different?
I just thought it was
Nope. So anyway, What's that telling us, other than I have way too much time on my hands?
That's confusing to me because I always took the line in between as 365 divided by, divided by 7, so you bring the top one up.
But you got to be kind of careful though. This isn't technically is not dividing by 7. It's the comparison between them. Yeah.
But do you need to put the 0.1428 level?
No, we don't necessarily have to go that far. We would round that off. In fact, we'd actually the appearance of the fraction we would probably hide in these. We'd probably round that as 52.14, and we'd write it as like miles per hour, like that. Where the appearance of the fraction actually gets pushed into the units. In fact, sometimes they get rid of it completely and they just do mph. But you have to be careful. Whenever you see that, you have to know what it means. For example, let's say on this road trip, we get 27 mpg. What's mpg stand for? Miles per gallon. When we see that, we need to think this. 27 miles per 1 gallon. Because this is the form it needs to be in order to be useful to us, to calculate with it. Now there are all sorts of rates out there that we use. We already saw speed and gas mileage. Most of you have probably experienced this type of a rate. $9 per hour, your wage is a rate. If you're in the medical fields, there's rates everywhere. You might have a rate of 2 milliliters per kilogram of weight, of mass for a patient. Or you might have a drop factor of, GTT is the abbreviation for drops per milliliter. What that does is it rates, when you're doing an IV, how thick the liquid is. A thicker liquid has fewer drops per milliliter. So if you're supposed to give them 200 milliliters per hour, you got to figure out how many drops that is that they have to get per hour in that IV.
You teach that as well?
Yes. And so rates are all around us. They're everywhere. Ratios are also everywhere, just not as obvious. I mean, we saw that some basic ratios with, student ratios and stuff like that, length to width or width to length. Let's take a look at some other common ratios. On the mechanical side of things, we're going to stretch your imaginations a little bit because I'm going to draw some pictures. And my artwork really sucks. Try to guess again. Nobody's going to make me feel better? Talk about gear ratio. Come on, those almost look like gears.
Well, yeah, we have mostly girls. You don't think gears, I don't think.
Gear ratios. What gear ratios are is the number of teeth in the driven gear compared to the number of teeth in the driving gear. How often do you see two sunshines hugging?
Look at those.
I have a 5-year-old.
They would rotate together, so that could be.
Their teeth aren't spaced properly? They're too close? Here.
So that's why.
Here, I'll make you feel better. How's this? There, is that better?
Much better.
Okay. Now it's obvious that they're gears? There. You guys make me feel bad about my artwork. I'm going to have to go home and cry myself to sleep again.
Well, you wanted us to be able to see what it was, and if they're not on there properly, so they're going to rotate with the teeth. Or are we supposed to be able to
Sure. So we count the teeth. There's 12 in the big gear, 8 in the little gear. How do we know which one's driven and which one's driving? We need more information, don't we? Let's say I do this. Pretend that looks like a small electric motor.
Hey, that looks like a small electric motor.
See, she got it.
She's good. Her name's Tammy.
So anyway, if I separate the gears, which one's going to stop turning? The 8, right? Because this one has the motor hooked to it, so it's going to keep going. That's the driven gear. It's being forced to turn by the other one. The 12-tooth gear, if I separate them, it's hooked to a motor. It's going to keep turning no matter what. That's the driving gear. So there's an 8 to 12 ratio. I can divide both of those by 4. Give me a 2 to 3 ratio. we might have a slope of ground outside your, on your land or whatever. It's often called the grade. The grade of a surface on the ground is given by rise compared to run. Yes, it is kind of. There's a certain slope. Slope is the term they use for that instead of grade.
I think it's like an inch to a foot.
Yes, 1 inch per 12. It actually was, they were going to change it to 1 foot and 20 feet instead of, so it'd be an inch and 20 inches instead of an inch and 12. But there were so many ramps out there that would have to be modified that wouldn't meet. In fact, most of the handicap ramps around here don't meet code. They're way more than an inch per foot.
Really?
Yeah. But they were grandfathered in because they were built before, or they were built without anybody knowing they were being built and then claimed they were built before the code changed.
Right.
So anyway, let's say that this rises 7 feet in 100 feet of run. Technically, a grade is usually done in rise per 100 feet of run. So this would be a 7 out of 100 grade. If we're talking about percents, they call it a 7% grade. Is that a steep grade? 7 feet high for 100 feet of run? Anybody familiar with Highway 8 over by St. Clair Falls?
Yeah.
Pretty steep hill down there. You know what grade that is?
What?
That's an 8%.
Really?
Yeah.
Huh.
So it's only 8 feet of rise for 100 feet of run. It's a pretty steep slope.
Yeah.
I believe it's at 6% that trucks are required to kick in the engine brake.
Really?
Yeah. So anyway, those are some of the more mechanical ratios. Some that you guys might be more interested in, since you're students, debt to income ratios. If you go to the bank to get a loan, this is just as important, in some cases more important than your credit score. What this is looking at your monthly payments. So let's say you have a pretty good job. Let's say you're making $30,000. You get $2,500 a month in income. Now we're not including the fact that you lose most of that to taxes. That's your gross income for the month. But let's say you have a home payment, a home mortgage of, we'll keep it reasonable. We'll go $600 a month. So you have a car payment of $300 a month. And credit cards, $200 a month. What is your debt to income ratio? We add this up. This is 1,100. So it's 1,100 to 2,500, which is an 11 to 25. That's actually about a 0.44 or a 44%. If you're above 30% right now, or 33%, usually a 1 to 3. So 30 to 35% is what they're looking for. So this person here would probably not be a good candidate for another loan. Medicine concentrations, there's a lot of ratios in those. So you might be asked to mix a medicine or dilute a medicine, is what they call it, where they want you to do a 1:6 dilution. And all that is you're adding 1 unit of medicine to 6 units of total volume. So if you have something that's 120 milliliters, that means 1/6 of that is 200 milliliters of medicine in that. 20 milliliters of medicine. Yeah. I wrote the right answer and said the wrong one, sorry. So anyway. Yeah. 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 1 part, 6 parts like that. The key is any ratio to understand what these are. Because a lot of people screw these up and say this is 1 part of medicine or medication to 6 parts water. Or what they use, NS is the term they use in the medical field for neutral solution, or normal saline, sterile water, basically is all it is. But that's not true. It's not medicine to water. It's medicine to total. That's one thing with any ratio. There's hidden ratios in it.
Really, see, I was understanding it the other way.
for example, we did that ratio of 6 female students, or 6 females in the room to 2 males in the room. Well, that's a ratio, 6 to 2 or 3 to 1, if we want to reduce it. But there's also a bigger ratio. What is the ratio of female to total people? Well, there's still 3 female, but there's 3 plus 1, there's 4 total people. So 3 to 4, 3 females for every 4 total people in the room. What's that? You give up? Well, the way to think about it, if there's 6 females and 2 males, that means there's a total of 8 people in the room, right? So it's just different ways of looking at it. You could have female to male, 6 to 2, or you could have female to total, which is 6 to 8, which reduces to the 3 to 4. Or you could have male to total, which is going to be 2 out of 8, or 1 to 4. Just whenever you have a ratio, you have to understand the ratio might be comparing 2 quantities to each other, or it might be comparing 1 quantity to a total. If I told you that, let's say 2 out of every 5 students who take this class fail. What are those? The 2 is the failures. I know it's not politically correct to call people failures. It's going to be you. There's that positive attitude we look for. 5 is total students. What if you wanted to be what do you want to know the ratio of students who pass to total? Yeah, 3 to 5. Because if 2 out of 5 fail, 3 out of 5 pass.
That was one of the questions on the one I think we have to do for tomorrow or Monday or whatever. Yeah, because I thought they were talking about failures because that's the number they listed.
Sure.
But then the question actually was the other number.
So what if we wanted the ratio of passing to failures? Well, out of the 5, 3 pass and 2 fail. So it's a 3 to 2 pass to fail rate. It's a little bit better than that for this class. Just so you know. Makes you feel better. So now that we have these ratios, what do we do with them? Well, there are a lot of things we can do with them. For example, let's say that we know that there is that 3 to 2 ratio of students who pass to students who fail. If I know that 27 students pass, and I want to find out how many fail, what am I going to do? I'm going to do this. I have that 3 to 2 ratio, and I know my new ratio needs to be equal to that. So 27 passing is going to go on top because 3 represents the students who pass. I want to know how many fail. So what we're going to do here, this is what we call a proportion. A proportion is just either 2 equal ratios or 2 equal rates. It can be either one. And to find the missing number, there's 2 different ways we can approach it. One is we can just flat out cross multiply. Cross multiply means we multiply on the diagonals. Like that. 2 times 27 equals 54. Then multiply the other diagonal. 3 times x, which of course is just 3x. Those 2 diagonal products, those cross products as they're called, have to be equal. 54 has to equal 3x. So now we're going to divide by 3, get 18 equals x. Now when you look at that, you realize all we did here is we multiplied these 2 to get the 54, then we divided by the 3 to get x. So there's a shortcut they use called just cross multiply and divide. Rather than doing the cross products and setting up the equation and solving, they'll just do 2 times 27 is 54, divide by the third number of 3 gives you the 18.
So you can't do like 27 divided by 3? That would get you nowhere?
You could.
What would that
It's
be?
just a long, it would get you 9, and then you'd have to do 2 times 9.
I would do that. That would be easy.
If that makes sense to you, that's fine.
Yeah, that must have been the way I was taught to do it.
They do around the loop
Yeah.
like that. Yes.
Yeah.
I've seen that taught. We divide first and then multiply.
Right.
Yep. Let's look at some others here. Let's say we have a 4 to 7 ratio, and we know that this is going to be 35. To find that missing number there, we're going to cross multiply. 4 times 35 is 140. Divided by 7 is 20. Doesn't always stay that simple, though. Maybe it's going to look like this. Simple. Might look like that. Now we got a problem. Here it might be easier to cross multiply. 9 times 48 is, anybody want to guess? 432.
Don't say the answer yet. I want to see if I get it.
8x times 27 is 216x. Those two have to be equal. So 432 has to equal 216x. So to solve that, I need to divide by 216. X equals 2. Or we might have something like this. Same type of deal. We're going to cross multiply. 7 times 88 is what? 616, I believe. You guys have the calculators, not me. Then we have 11 times x plus 3. So 11 times x plus 3 goes in parentheses there. So now 11 times x plus 3 equals 616.
Yeah, so I didn't get that.
Everybody see where this comes from so far? Any questions? You don't want to go back and... No, we got to solve that yet to get the answer. Now we see the parentheses. Is there anything we can do in the parentheses?
No.
No. To the parentheses? Yes, times 11. So 11 times x is 11x. 11 times 3 is 33. It's a positive 33, so we do that. Equals 616. Now what do we need to do? We'll subtract 33. 11x equals 583. And then divide by 11, x equals 53. Questions?
Yeah. Will you do another one of them?
Sure, I'll do another of each of these probably. Or two. Oh, let's see here. Let's try this one. In fact, I'm going to let you guys try this one in your seat. So, we'll do 9 times 75, which is 675. 5x times 45, 225x. Then what?
I didn't do it your way. I just got the answer.
So 225x equals 675. We'll divide by 225. We get x equals 3.
You got
Right?
that.
How'd you get it?
I did.
How'd you get it? Just I
Well,
want
look
to know
at-
your process
I
was.
got it. Okay, so 9 times 5 is 45. 5 times 5 is 25.
So 5x equals
times
25. Okay.
But not when you get like the really big numbers.
That's still when you get to the larger numbers, that's not going to work very
Then I
well
know
for
then
you.
I gotta learn. That'll-
There is another way you could have done this. You could have done 9 times 75 divided by 45 is 15. That tells you 5x equals 15 and divide by 5. Get x equals 3. That works well as well.
Okay.
Just I find people make less mistakes when they do it out the full way. Yeah. You have to keep track of the fact that you're not getting the final answer, that you still have to write out the equation and solve it. Oh, let's see here. I'm gonna let you guys try this one quick. So let's peek at this one. We're going to cross multiply. 7 times 75.
525.
525. Y minus 4 times 35. I'm going to write it this way. 35 times y minus 4, just because that's easier for me. So we have 35 times y minus 4 equals 525. What do we do? Distribute the 35. 35 times y is 35y. 35 times negative 4, negative 140. And then add 140. 35y, add 140 over here is 665. And then divide by 35. So y equals, there you go, 3. Perfect. That looks like a perfect time to take our break. So we're going to do that.